This section is on functions. We'll do everything from function notation, evaluating functions, finding domain and range of functions, and also something called the difference quotient we will discuss. So the first thing is, what is the basics about what a function is? Well, first, a relation is a pairing of elements of one set with elements of a second set. So you're just matching things up in terms of two sets. We go a little bit deeper in terms of a relation. We can also have something more specific called a function. Now, a function is still a relation, but each element of the domain is paired with exactly one element of the range. So you can't have one x going to two different y values. You can't have your independent variable having two different dependent variables. All right. So independent, dependent. Independent is your domain or your input, which is your x value. So your x value represents, all your x values represent the domain of the function or the relation. Dependent variable is the range, which is the output, typically your y value. Once again, your range is all values of y for that particular relation. A couple of things we're going to talk about to determine if a relation is a function. First, if you're looking at a graph, we do the vertical line test. And the vertical line test, you just draw a vertical line and basically pretend moving that across the graph and see whether it has one x going to two different y's. If you're looking at ordered pairs, you're comparing those x values. Do you have one x going to more than one y value? And then the last one, maybe one a little bit more challenging, is when you have an equation, if you know what the graph is, that will kind of go back to the first one, which is the vertical line test. If you don't know what the graph of that equation is, then what might be helpful is to solve for the y value. And when you solve for the y value, you'll be able to tell whether you have that 1x going to two different y's. The first example we're going to look at is example 1. Decide whether the relation represents y as a function of x. So what we just talked about, and make sure you explain what your answer is. So on the first one, just a set of ordered pairs. All right, what are we looking at? Well, we have 6 going to -5, 1 going to 0, -9 going to 3, and 6 going to -1. So does it represent a function? Do we have an x value, our independent variable, going to two y values or more? And you can see that the 6 and this 6 are going to two different y values. 6 is being mapped to -5 and 6 is being mapped to -1. So therefore this is not a function. Oh, that didn't work the way I wanted to. Let's change that. So this is not a function, so no. Decide whether the relation represents y as a function of x. And then the explanation is, at x equals 6, it is mapped or goes to two y values. And there you go. So just make sure you explain, doesn't have to be exactly that, but something about x is being mapped to two different y values as to why it's not a function. B. Now B is a graph, so you can use that idea of a line and just taking a vertical line and moving it across the graph and seeing if it ever intersects more than once. And you can see multiple times across this one, it will intersect more than once. So once again, is this graph or this relation a function? And the answer to this one, once again, is no. The reason, you can just say, because we use the vertical line test, we can say that it failed the vertical line test. And there you go. Example C, x squared plus y equals 1. You might know what this looks like as a graph, but if you don't, remember what I said. You can just solve for the y value. So we get y equals -x squared plus 1. And when you think about that, y is equal to -x squared plus 1. You guys should know that's a quadratic. It's a U-shaped graph. We'll talk about transformations. It does open down because of the negative. And so y equals, when you plug in an x value, let's just plug in, let's say 1 for example. 1 squared is 1, that would be -1 plus 1 is 0. You don't get back two different y values, you only get back 1. So this would be a function, so yes, And the explanation, you can say something about x is paired with exactly one y value. Every x is paired with exactly one y value. All right, and then on D, we have x squared plus y squared equals 9. Once again, this might be one that you recognize, and if you do recognize, it is a circle. And so that kind of answers your question as to whether it's a function or not. If you didn't know what that is, you could solve for y. You'd have to subtract the x squared and then square root. So you get y equals plus or minus the square root of negative x squared plus 9. So now when you think about this one, if you plug in a value here, such as, let's say, 2 squared is 4, negative 4 plus 9 is 5, but you get plus or minus the square root of 5. So when I plugged in x equals 2, I got two outputs. I got square root of 5 and negative square root of 5. So I'm getting two y values for every x value. And once again, it is a circle, so you can see that as well. So depending on how you knew that, you could say no, doesn't pass the vertical line test because it's a circle. Once again, or you can say, no, x maps to two different y values. And so that's how you can tell whether a relation is a function. And like I said, make sure you do give that explanation. The next part of functions we're going to look at is function notation. F of x equals the value of the function at x. We're going to look at this a couple different ways here. We have the independent variable f of t equals negative 16 t squared plus 20. So the f represents the function, and then the t is your independent variable. C of h is equal to 30h plus 50. And so really what's happening, it doesn't f, I put v of something, it's actually the earth. And it doesn't matter what this variable is, what this symbol is, as long as when you go to write your expression equals 4/3 pi, that same symbol of the earth cubed. So as long as those two are matching up, you're writing it in function form. And you don't have to always use f. You can use other variables to represent your function that you're talking about. So on example 2, given functions f, g, and h, we're going to evaluate the functions for the given x value. And so we're going to do this on another video, but I just wanted to give you the chance to kind of look through those, and I'll get back to those examples in a little bit. And the last thing about functions we're going to talk about is the domain of a function. So the domain of the function, which we talked about in the beginning, all real numbers, and here's kind of a key to this, all real numbers for which the corresponding values in the range are also real numbers. So when you start looking at this and you say, well, you could have, an output of 3i and start getting into the imaginary complex numbers, domain of a function, we're only talking about the real numbers on these examples of what we're doing. So on example 3, I have 6 different things that we're going to look at. But for now, in terms of the notes, we've covered functions. We've covered a lot of different things about functions, from function notation, evaluating functions, finding that domain and range of functions we'll talk about, and then evaluating that difference quotient, which I'm going to do in the next video.